So here we have this problem, number 4, and it says maximize profit for X1, X2, and X3. These are 3 products that are supposed to be produced. And you can see that we have the per unit profit of X1, which is 3, and the per unit profit of X2 is 2, and the per unit profit of X3 is -1. And we have a number of constraints that this process will be subject to. So we have input 1, input 2, input 3, and input 4 through 6. You can see that input 4 through 6 are the non-negative conditions where we have X1, X2, and X3 that they should be greater than or equal to 0. They should not be negative. As we discussed before, we saw that we cannot produce any item which is negative. We may not produce, and that is 0, or we can produce some products. And therefore, we will maximize our profit either by not producing or by producing something. And so X1, X2, and X3 should not be negative. They should be equal to 0 or greater than 0. So in this case, we are supposed to solve this equation by using solver. And so we can use Excel, and we can create our model. And so let's assume this is a ABC company, and this company produce items or products which are X1, X2, and also X3. And let's see the quantity. So we're trying to find how many quantities that this company will produce in order to maximize profit. And so we can put any values. Let's say we can put zeros or 1 or any value. So let me just go with ones for now. But these are the changing. These are the changing variables. They are changing variables, meaning that we are going to vary them, meaning we will need to produce up to the point where we can maximize our profit. And so these values will actually change. And let's look at the inputs. We have input 1, and we can copy this to input 1, 2, 3. And you can see for X1, in case of input 1, we can use 1 input to produce a unit of X1. And that's what we see here. So I'm going to put 1 X1. And here we have 3 for X2, meaning that input 1, we can use 3 per unit of X2. And so we're going to put 3 of X2 here. And also we have 1, so I'm going to write 1 for X3. So let me go with input 2. In this case, we have 2X1, meaning that we will need 2 of input 2 to produce a unit of X1. So I'm going to write 2 here, 2X1. And we have 3 here. So I'm going to write 3 of X2. We have minus X3 here. So that means we have minus 1 times X3. So let's go with input number 3. We have 3X1, meaning that we will need 3 of input 3 to produce a unit of X1. And we will also need 2 for X2 and 1 for X3. 3. So those are the inputs we have. Now, remember here we are told that x1, x2, and x3 should be greater or equal to 0, and these are inputs 4 through 6. And so I'm going to write here x1, x2, and x3. And so we're going to look at the conditions for this requirement, which actually we have it here, which is non-negative condition. So let's see used resources. We're going to see how much of these inputs are used when we make a decision to produce x1, x2, and x3. So let's take an example of input 1. So assume that we are producing 1 of x1, 1 of x2, and 1 item of x3. So how much of input 1 we are going to use? Remember that these are the changing variables. We can change them at any time. And when they change, also the required inputs will change. For instance, let's say if we are to produce 10 units of x1, then that means we're going to require 1 times 10, and therefore we'll spend about 10 of this input 1. And so since these are going to vary, then we'll put equal sign, and we will use sum product function. And so we're going to select these inputs that we are using from input 1, and then we'll make it times their corresponding quantities which we'll produce. And in this case, we can enter. So if we are to produce 10 of x1, 1 of x2, and 1 of x3, then that means we're going to utilize 10 of this input 1, because it will be 1 times 10, 3 times 1, and 1 times 1. And so when you add all of them, you will get 14. That's why we used sum product function. Now, how about input 2 and input 3? We're going to do exactly the same, and they will all refer to these quantities. And so we can copy the formula which we used here. However, in this case, we need to lock down this particular cells, the 3 cells. So we will lock down those cells by putting $sign around the cell. So I'm just typing the $sign, but actually you can click on F4. That will give you the $sign. So in this case, we have put the $signs, and so we have logged this 3 cells. And in that case, all these other inputs will actually refer to this particular cells. And so all you can do is just copy the formula way down. You can check the formula, you can see where it is correct, and all the way up. So those are the used resources. Now let's assume that we don't produce anything of x1. You can see that the used resources will also change. And what if we don't produce anything? So if we are not producing anything, you can see that we are not using our resources. And so when we use the function, it will change as the quantities produced change. Now we need to consider limits. We're going to see what kind of limits we have. Now in this case, we have to go back to the equation here. You can see that we are limited by 9 units of input 1. But for the second one, we can use 2 inputs or more. And for the third input also, we can utilize 5 or more. Put those limits here. So the first one is less or equal. And here we have greater or equal. And so we can copy the formula for the second or for the third input. Now we will need to use the limits for x1, x2, and x3. So let me copy this limit way down. And if you can remember this condition, this should be non-negative. So let me put constraints here. So in this case, we know that we are limited for this x1, x2, and x3. They shouldn't be less than 0. They can be 0 or more. So in this case, we need to find what is x1, what is x2, and what is x3. So what we are going to do is we will put equal sign there and click on the quantities for x1, which is this cell. And if you enter, we have 0 because we have 0 here. And if you put 1, you will see that this one also will change. So let's go for x2. You can put equal sign and click on the quantities of x2, or click on this cell in x2 and then enter. So you will see that it is 0 because we have 0 quantities of x2. If you put 1 there, you can see that this one also changes. Now let's go to x3. We are going to click here as well. You click there and enter. Remember to put the equal sign. So put the equal sign and then click on the quantities of x3. And if you enter, you can see that we have 0. You can test this by putting 1, and therefore you can see this will change. You can change any quantities. Let's say you put 12, and they will also change here. We have 12. So now we are done with the used resources. Now let's go with the constraints. We need to fill these constraints here. Remember, we are told that input 1 will be less or equal to 9, but input 2, we have to use more than or equal to 2 of this input. And for input 3, we can use from 5 and above. So let me put those values here. We have 9, and then we have 2, and then we have 5. So those are our constraints. Now we are going to include the per unit profit. And then we can get our profit, the maximum profit. And so we are going to see what is the per unit profit of x1. If you look at this question here, you can see we have 3 x1, and so we're going to write 3 there. Here we have 2 x2, so we're going to put 2 there. And here we have minus 1, and so we'll type minus 1. And those are the per unit profit. Now let me put profit there. And so we can say the total profit. So I'll put equal sign. You can see that this per unit profit will also depend on the quantities that will be produced for x1, x2, and x3. And therefore, we will need to use some product function. And we can highlight all these per unit profits, put comma sign, and then highlight the quantities. Close the bracket and enter. So at this moment, profit is minus 7. That means it is loss. We are getting loss at this moment. If we are to produce an item of x1 and x2 and x3. So up to this point, we have created our model, and you can actually test it to see if we have done it correctly. Just put the zeros to see if what will happen. You can see if you put all zeros, meaning that you are not producing, then we are not using any resource, and also profit will be 0. So that's how we can create our model. Now, the next thing to do is to use Solver to solve this problem. I am using Mac, and therefore I will go to the tools, and then I'll select Excel add-ins. And in this case, I'm going to check Solver add-in and click OK. If you're using Windows, you know how to put add-in. We did this in class, and I'm sure you can remember about it. And so let me click on the data, and then I'm going to click on the solver. So, but before I do that, let me close this. Close. So you see this profit is our objective, and therefore I'm going to write here set objective. And let me go back to the data solver. So here we are asked to click or to input here the set objective, and you can see that our set objective is this value here, or the profit. And then we are supposed to see if we are maximizing or minimizing or getting a value. But the question here says maximize profit. So we are maximizing profit. And we can maximize profit by changing variable cells. So these are the cells which we are going to change. So here we have changing variable cells. So we'll select all of them. And then subject to the number of constraints. So I'm going to add constraints. Click here. And let's see what constraints do we have. Our constraints are defined by the limits which are given. And so we can see the first constraint is we can use this particular amount of input 1 up to 9. We don't have more than 9. So this constraint here, we're going to click here, they use the resource. So it should be less or equal to 9. So I will click this cell here. And then I'm going to add. You can see that these limits, they are all the same, and they have corresponding constraints here. So I will select all these use resources, and I'm going to change this limit. So we're going to have greater or equal to. And then I'm going to select all these values. I think that's with the constraints, and so I will click OK. So we have our constraints here, and we need to make unconstrained variables non-negative, and we will use simplex linear programming for now. We're not considering the integrality condition, and therefore, and all we have to do is to solve. Now, when you click solve, you'll get this information here which says all constraints and optimality conditions are satisfied. If you won't get this, then that means your approach is wrong, and all you have to do is to check where you make mistakes and correct them. So in this case, you can see that we can get maximum profit, which is 27, if we can only produce 9 units of X1 and none for X2 and X3. And in this case, we'll be able to utilize 9 of input 1, and we're going to utilize also 18, which should be greater or equal to 2, and 27, which should be greater or equal to 5. In this case, we will maximize our profit.